thank you. Before starting the talk, I want to have a big poll. How many of you have done load testing or performance testing once in your life, at least? 1, 2, 3, 4, yeah. And how many of you that have heard about performance testing or load testing once in your life? Only heard? Oh, yeah. Okay. Yeah. I put the slides and also the codes there, so if you want to get it, just write it, just go to there, don't need to get a photograph. Okay. Yeah. This talk I want to talk about load testing and performance testing with tools in Python called Locust. I will talk about the conceptual load testing concept about load testing and also the tools in Python called Locust. And before that, let me introduce myself. My name is Abdurachman Mappuji. You can call me Mappuji or Puji. Currently, I'm software development engineer in test at Mitrans, payment processing company in Indonesia. I work in the intersection of development and testing. That's why I present Locust here. I also in free time contributing to open source project called Open Learning Exchange. I basically create learning platform for rural area. That's all. And you can find me in my GitHub, github.com/Mappuji, or my weblog, mappuji.org. Yes, it is a load test in a nutshell. So basically, when we talk about load test, basically you want to know in what load our system will fail and how our system will fail. That's two questions. And those two questions will derive many other questions. And before that, because I see that there's not so much of you heard about load testing and also done some load testing, I will give some terminology to make you better understand load testing and performance testing. So the first term is load testing. So what is load testing? Load testing is a subset of performance testing. It's basically you give your app, your system with a certain load, and you want to know over a period of time what will your system behave. It will fail, or it will going okay or not. And there is another term called performance testing. So basically it's a superset of load testing. So this is how performant your app, how performant your system. And it usually involves load testing, but not always. Sometimes you can measure the performance not by load testing. And the third thing is performance profiling. It is a different term. So basically in performance testing you are treating your system as a black box and you are giving a load and test your app, but in profiling you test a section of code instead of the whole app. And it is profiling takes time because you profile each section of code you interact with, and basically 80% of the time you can find 80% problem with your app with load testing, performance testing. So at least you have no idea, or your load testing is give you no clue, you can try performance profiling. And the other term is called benchmark testing. So basically, with your app, you give your app certain benchmark, and you can run some benchmark in maybe daily builds on your pipeline. And then you want to know early if there is any code change that makes your app slow. And there is another term called scalability testing. So basically, maybe you have already an app in production, and then with certain resource, with certain setup, load balancer, cluster, and everything. And now, if you want to add another resource, perhaps it is increase in hardware, more RAM or more processor. Oh. More RAM or more resources, and you want to know, is my app will the performance of my apps increasing with this increase? So basically, if we increase the RAM, the CPU, or we add new nodes in our app, is the throughput is increasing or not? That's the scalability testing. And another thing is availability testing. So you basically what is tied to reliability, and it's basically you want to know if the system fails, how quickly the system backs up, and maybe you want to test what time is the mean time to failure and mean time to recovery. That's all. Okay. And okay, so maybe you are wondering when we need to do performance or load testing. So basically, you can do performance or load testing when you have this kind of question. First, is my application or system meets our customer want? And you can verify it with load testing or performance testing. Basically, if you have, for example, e-commerce app and you expect that every day there is a certain amount of user that visit your app, you want to know is meet your need or not. And second, maybe you want to if a backup data that's backup your sales or marketing program. For example, you have an app. For example, Google has an app that sell to the enterprise, and this app can read query with certain query per second, X query per second, and you want to back that marketing claim with your data, your performance testing. And maybe you want to do hardware updates, and you want to know if you increase your hardware updates, is our performance increasing or not? Or you want to choose some vendors. And last, performance testing is not functional testing. So if there's someone talk to you and hey, I need your help to do some performance testing or load testing, and because I want to know our apps is functional properly or not, that's not performance testing, that's functional testing. You need to ask other people in parallel maybe to confirm the functionality. Okay. Then the test setup. It is the most important. So basically for doing load testing, at least you need these 5 moving parts. First is system under test and load generating machines, which is Locust, we will talk about later. And then monitoring machines with monitoring software, of course. And data repository, because load testing and performance testing produce lots of data. And 5, if you have your data in a database, you want to access it. You need to data access and data display. And this is a diagram of typical load testing. I take this from some framework of Google. So basically Google, they are doing testing like this. So we have system under test. So maybe it's not a single app, maybe it is a cluster or a complex apps with API gateway and everything. And we have load generating machines, and then we have monitoring machines. And those 2 machines give the data to result parsing and aggregation, and then all the data is saved into the database, and we can access via presentation layers. It is an ideal case. But sometimes, maybe for a small exercise, you don't need the left-hand side, so you just need some right-hand side. Okay, so comparing tools for load testing or performance testing, there are several tools, first in-house, and also there is vendor tools and some open source tools. Each tool has advantages and disadvantages. For example, start with in-house tools. So in-house tools, the advantages is we already have the code because it is a side effect of development. Sometimes when we do development, we create some script that it is simple and we just need to add some lines and we can turn it into a load testing script. And easy to use because someone who made it is in our company. And third, source code are available. But there's disadvantages. It is cannot be shared to public because it is proprietary code, of course, and the validity of result is questionable outside of the company. Maybe it's valid, but outside of the company you cannot share your code. It is not valid. And the tools on maintenance can be costly if you want to maintain the tools. And last, sometimes you just create yet another tools. Why not reinventing the wheel? Okay, there is another option which is vendor tools. So the advantage of vendor tools is it support many different protocols, not only HTTP, maybe it's IMAP, SOAP, and many others. And it's professionally developed because there's a developer there. And result and scripts can be shared outside the company because other people can buy also the tools and try the script. And also there's disadvantages, which is it is extremely costly. And it uses proprietary scripting language, and you need your developer to learn that scripting language in order to do some tests. And no access to source code. It means that you have to pay money to request a feature. No money, no features. And sometimes they are putting a pretty graph that your executive level wants, but it is meaningless. But there is open source tools. It is good price because you can get it for free, but in return we can contribute back to the community, and we can also give back our modification. So we can pull requests to the upstream, and maybe our modification can be received. And easy to share the result because it is in the public domain, that you can tell the people that we are using these tools with this kind of tests. It's reproducible, and the source code are available. That's why you can modify it and maybe get pull requests. And usually it uses a standard scripting language. Maybe some others using their own DSL, domain specific language, but most of the case is using scripting language that's standard. But the disadvantage is the support for different protocol is limited. So not every protocol supported, so maybe you need to have some modification there. And in some case, it has a steeper learning curve. Okay, and then I will compare some open source tools available, but I took the most popular, which is JMeter, and also Locust, which is the Python tools that recently popular. So it is both are run in any operating system, and both are open source. JMeter has a GUI mode and also web, but for Locust it has no GUI. It's only command line. And for the execution monitoring, for Locust we only have console and web, but JMeter has GUI, but not a big deal. And for support test as code, so basically this where Locust strong because it is support full programming language, which is Python. But for JMeter, it's using XML. But for the protocol support, right now Locust only supports HTTP. There is another comparison. So first is JMeter has integrated monitoring, but Locust not. And JMeter does they can do recording, but Locust not. And also, for the distributed execution, both have the capability. So basically in Locust or in JMeter, we can set up a load generating machine distributed not only in a single machine, but in many different servers. And for easy to use with VCS, version control, Locust is better because they're using Python. And for the resource consumption, Locust is slightly better because it is using coroutine instead of thread, so their simulator user is not bound to thread. And for number of concurrent users, both can simulate thousands of users, but for JMeter, it is bound to thread, but for Locust it's not. And for ramp up flexibility, if you want to create a ramp up function that your user is going ramp, for JMeter is very easy, but for Locust you need to do some tweaks. But yes, but last in test results and analyzing, both are giving the same functionality, but for Locust is kind of limited. Okay, when Locust fits your need. Okay, if you want to test thing HTTP app, maybe it's fits your need, or you want to high throughput load generating machine but with less resource, maybe Locust is best for you. And if you want to have a distributed load generating machine, maybe Locust is good. And if you want to generate complex use case scenario, for example, you have an app in production that every peak hour, for example, at 2 p.m., you have, for example, 40 premium user and 10 regular user. So you want to simulate many different scenario there. Python and Locust is kind of better because you can create the simulation in the code with Python. And last, maybe I forget to put, but because it is Python. Yeah, So basically, if you want to try Locust, just doing pip install Locust IO. That's easy. And because we want to give our script a meaningful name, just put everything what you want. That's something that fine. So in this case, I want to give some example that testing a to-do app API. So basically, I create a very simple to-do app API, and want to test them with Locust. So here is the code. I hope you can see it, but if not, my slide is in tinyurl.com/pycon-locust. Yeah. So basically, in this script, it is like giving us all the information about Locust. So basically, we just import the Locust, and then basically all our user behavior or user scenario are in user behavior class, and in that class we have several tasks, and we can give them weight. So in this case, our get task has weight 10, and our post task is 1. So basically, we are simulating ratio 10 to 1. Yeah, so basically 10 for get task and 1 for post task. So every 10 get task will post task. Okay, is weight. And then it's basically Locust basically using Python request library. So everything in Python request library we can use here. And the most important is name. So in self-client get name, so you can give your request name, make it different from others, and it will invoke in class website user. So basically, there is two parameters, min weight and max weight. So basically, min weight and max weight is the time that each user will hit a new request. They choose a random value between min weight and max weight before invoke a new request. And if you want it is constant, you can have min weight and max weight the same number. Okay. And if you want to try, just Locust, just F, the name of the file, the directory, and then host near host. And then open your browser in localhost 8089. I will give you a demo later. And it will running a single process. Later I will talk about how to run it in multiple processes. And here is the thing that we need to know, the number of users. So I will give you some demo. So basically, when we run a test, there will be a prompt like this: the number of user and the hash rate. So basically, the number of user is the number of simulated user that will run our use case scenario, and hash rate is the rate of our user. So basically, we want to give warm up to our server that it is not suddenly 10 user, but it is maybe 10, 1, 2, 3, and then 10 linearly. Okay, so I go back to slide. But there is some problem here. Locust use Python request that by default has no timeout. So basically, min and max weight is the new request will hit if you receive a response. But if you haven't received a response until the max weight exceed, you will still waiting for response unless you give a timeout. Or maybe you are wondering how to make a asynchronous request that doesn't necessarily waiting for response, but after a certain amount of time, just hit again. We can do that by using Greenlab coroutine concurrency model. So basically, we just wrap our class there into a G-event function. Then that's all. It's very straightforward. Then after we use this, we can have a asynchronous request. So basically, the request is not waiting for timeout, but after the wait time is enough, it will get a new request. And here is the example if you want to run your Locust in different processes, in multiple processes, not only one. So you can create a master and then create a slave. And then you can also open the browser like usual. And things outside Locust. So basically, Locust is great in load generating machine, but it is not so good in that data visualization and data collection. So you need another tools to make your load testing, performance testing better. And there are some things that you should record, something like app log. When your app maybe crash when you are doing tests, you need to see the app log, and then app monitoring, recording exception, error rate, success rate, etc. And you can also monitor the resource utilization of your host machine. And if possible, put the record in the database. Because maybe if you run the test gradually, and you need to, maybe 3 months after now, you want to look at the database and see, oh. And summary, performance and load testing is important to find performance bottleneck or system under test for our software. There is several options for testing loads, include in-house, vendor, or open source. And Locust is one of the open source performance testing tools that has better functionality in creating high throughput, low resource, low generating machines. And because it is support full programming language, which is Python. And in it, there is part of testing set up outside Locust that we know that testing is best done if we do the test and experiment in a good way, in proper setup, and in proper analysis. And this is the difference. How many times I have left? Maybe I'll give you some demo. So, for example, here I already in yeah. No. I will demo it a simple one because time is limited. So it is doing test to this host. It's a simple to do app. And I will open my browser, push, and I refresh, put 10. So here, first they will hatching the user, and then here is the statistics tab. You can see the average time, min max, and everything. Here is the dashboard, the request per second, and how many failures, number of users, and this is the chart. Total RPS, request per second, and also the average response times and number of users. So first we need to hatch our user, then we have a step input like this. And if there is any failure, it will report here. So if there is an exception throw, it will show here. You can also validate your response. So basically, you want to check your app. Is it return the right result or not? You can verify here with some stuff in the code, and if there's an exception, it will be showing here. And if it's already done, you can download the CSV for the statistics. That's all. I think. That's all. Do you have any question? Yeah.
First question, does this support Python 3?
Yes, I'm using Python 3, but I haven't used Python 2 for Locust.
Okay. Next would be, I was interested, like, when you want to use some kind of testing, yes, you use gevent instead of the async IO, which is a standard library. Can you tell me why?
So basically, I'm doing like that is because it is more easy to convert my code into concurrent asynchronous way of calling API. Because when I have tried async IO, if I'm not mistaken, but it is kind of hard to convert my code. So I'm just using this because it is more productive. Maybe another question? Yeah, please.
Can you have a distributed testing? If you have more than 9 machines, like test?
Yes, of course.
Possible.
Yeah.
Okay.
So basically, there is So here you can do something like this. So you can set up your master, and then you can try your slave here in different machines. But it should be accessible. The master should be accessible on the internet or in the same network. Maybe a question?
Oh, I have a question.
Is there any other question? Still have bit time.
Data output is just CSV.
Data output is only CSV with the statistics, only the the percentile, and every basic stuff.
No JSON.
All the output is in JSON, but it is but the number of record is limited. So it's only showing our statistics.
So for example,
I will download the CSV here. Exception statistics. I forget, but I think there is a way to make it JSON output. There is no question.
Okay, I think if there's no more question, thank you very much for coming to track 2. And if you have
Thank
more
you.
questions to Puji, you can ask him directly. I think he will be around, right? Please give applause to Puji.